Rutherford's nuclear model of atom. The Rutherford's atomic model shows different properties of atom such as existence of nucleus, nature of the charge of the nucleus, and the magnitude of the charge of the nucleus. In order to explain the Rutherford's nuclear model of atom, what I'm going to do, I'm going to use some materials. So my materials are alpha particle, gold foil, zinc sulphide screen, and electron gun. So in order to explain this, I'm going to use all this information to draw a figure. So here is my figure where you can see this is the gun and this is the radioactive substance. And radioactive substance is releasing the alpha particles. So these are the alpha particles hitting the gold foil. This is the gold foil and this is the screen. So basically what happens, this is the radioactive substance and the radioactive substance releases the alpha particle, and as soon as the alpha particle hits the gold foil, then either alpha particle reflected more than 90 angle or less than 90 angle, but some alpha particle they hit the screen without any deflection. So the observation that we have is, the first observation is most alpha particles were passed through the foil undeflected, which simply means that most of the alpha particles did not get deflected. Very few alpha particles were deflected when passed through the foil. So out of all these ones, very few were deflected. And the third observation was 1 out of 8,000 alpha particles were deflected at 90 degree or more angle. Now let's talk about what are the conclusions that we have. And the first conclusion that we have from the Rutherford's nuclear model of atom is major portion of atom is empty. The second one is the mass of the atom is concentrated at the center of the atom, which is called nucleus. Our next point is, which is point 3, nucleus has positively charged particles. Point 4 is the electrons revolve around the nucleus in different orbits. Our fifth point is the charge on the nucleus is plus Ze, because nucleus is a positively charged, where Z is the atomic number of the atom and E is the charge on the proton. And the last point is the size of the nucleus is very small in comparison to the size of the atom. So basically, if you look at all these conclusions, you can say that the nucleus is a positively charged, very dense, and the electrons revolve around the nucleus in a circular orbit. Now, the force of repulsion between the alpha particle and the positively charged nucleus is given as F is equal to 1 over 4 pi epsilon 0, the charge on the alpha particle, which is plus 2e, times charge on the nucleus, which is plus Ze over r squared. So basically, in order to find that repulsive force, what we are doing, we are using the Coulomb's law to find the repulsion between alpha particles and positively charged nucleus. And this is how we'll define the Rutherford's nuclear model of atom.